you know, again, I'm Bill Robertson. I'm the Extension Cotton Agronomist with the University of Arkansas System Division of Ag Cooperative Extension Service. Bosses are real happy when you put all that stuff in there, aren't they?
Don't leave the system out.
Yeah. But when I looked at the title was Precision Irrigation and Its Place in a Practical System. So I thought I'd try to, I'm going to kind of introduce a little bit and then turn it over to Steve. But you know, most of the time, you know, when we get stuff out in the real world, it don't always go as planned, does it? And Mother Nature tends to help us out sometimes, and sometimes she helps us more than we think. But you know, when we think about irrigation and all that, I do cotton, and so in some of the visits with you and Tim, you know, we talked about, okay, you know, let's think about this for a second. Why do we grow cotton on beds? And the main thing, you know, cotton doesn't like wet feet, and we grow cotton on beds, I think, as much to get more water off the field than we do to get water on the field. And when we get into a situation, you know, the way we're farming now, we have very little soil structure. And so our internal drainage is almost nothing in it. And so when you have almost no internal drainage, external drainage is all you have. And you have to have a really big bed to get the water off to be cotton's liking. So when we talk about this and go on again thinking about practical situation, most of our cotton's on silt loam soil. And when we look at silt loam soil, how many of y'all recognize something kind of like this? I know you do, Steve. Because what do we see? Well, we got water running down the middles, and it's probably been running on I like to have a 12-hour set, but that may have been running on a 12-hour set. How far is the water soaked up to the top of the row? About halfway. All right, so we decide, okay, well, we want that water to soak up a little more. Let's run it for a few more hours. What's going to happen? It's not going to soak up anymore. We're just going to fill the ditches, aren't we, Steve?
Yeah, with Discovery Farm, we were able to do that very thing. We had sensors under the row of the cotton, and we had irrigated the third time, and our cotton, our irrigation specialist asked me when we were going to start pumping. I said, well, we've already had 3 cycles. And so we said, all right, we're just going to run 12 hours. We're going to absorb something in those sensors. And guess what? The fact that we could measure it, every drop of water that we pumped went back out of the field. We didn't do, and the soil sensors never moved. That's when we discovered something about soil health.
Yeah.
And after cover crops, instead of having that, we could take that same soil and we could make that look wet just like buckshot all the way across.
Yeah.
Is that something to do with cover crops in the middle? It's slowing the water flow, or is that allowing the infiltration?
I think it's improvement of soil structure, and we get better water infiltration. And we've got some water sensor data in a little bit. I think that'll show that. But this, you know, we got this. This is what we look at. This is what we see. And things aren't always like the picture in the book. You know, this is some information from Dr. Easterhouse's publication. But when cotton's running about 14 inches deep, then generally in a situation where we don't have restrictions on root growth, we should have 50 days after planting. We expect the first flower to be 60 days after planting. So a little bit before flowering, we should have a root system that's 36 inches deep. And you know, I've been in fields, in Steve's fields and other farmers' fields. Sometimes we do deep tillage in the fall. Sometimes we do it in the spring. But I've gone in there with the metal rods or like a penetrometer or something like that. And in the fall and in the spring, after we've done our deep tillage, just take a metal rod, slide all the way down the ground 3 foot. And at planting time, right after behind the planter, still able to slide that rod 3 foot in the ground. And then about the time we get to squaring on cotton, start hitting some resistance about 3 to 6 inches pretty good. And if we're in a year where we don't get a lot of rain, by the time we get the first flower, I cannot get a metal rod to go past 6 inches. And so we don't get that root system like the picture in the book. A lot of times we have something that looks like that. I mean, y'all see.
Why did that change, just like you described? Why did that change?
I don't know. I've asked people, is it a chemical thing? or is it a physical thing? You know, we have some soils that, you know, we have the frangipans, we have getting into problems with low pH, liminal toxicity, and all those different things going on. And I don't have a good answer for that.
But I think that's almost a given that occur. I don't know that
Yeah.
I've seen it doesn't occur.
But it's like year in and year out.
There you go.
Now, if we get a really wet year, a lot of times, and I've gone into fields before when I had a hard pan like at 4 inches, I could not get through. And we get a spell where we got 3 or 4 days of wet weather and rains. Well, then all of a sudden you get enough rain and I guess enough, not really pressure of water, but exposure of water to that it finally makes it through the hard pan. Because, you know, during the winter, when we get all the rains in the winter, like, you know, the 50, 60 inches rains that Dr. Reed was talking about, we get that and it finally gets all the way through, but we can finally get some of that through that hard pan. But in irrigation, we are not going to get an irrigation through that 6-inch hard pan. So we end up with something like this. And so when we do that, that makes our irrigation recommendations, it makes it real difficult when really all of our water, and I go in behind irrigation a lot of times with a soil probe and see where the water went. You know, a lot of times I hit dry soil about 5 or 6 inches deep. And so if you hit, you know, we got the top 6 inches where we have moisture and it's dry under that, we're not taking up the potash, we're not taking up the nitrogen. We're just restricted. I feel like we're almost handcuffing that plant to make it do all of its work in the top 6 inches.
Flower.
Yeah, yeah, and we're in a spoon feed situation, and, you know, we're doing that when we're farming like this, and that's the way a lot of people farm. You know, sometimes it's one of our biggest challenges. Planting time is too wet to plant, so we work it to dry it out. And then we pack it. We get a compaction zone, and sometimes we get grown up like weeds, but our water won't soak in. So we're starting to do some things with Steve and some others, going into a cover crop and looking at some different things, and we're seeing some advantages. But I'm thinking right now to really get into the meat of the program on precision irrigation and its place in a practical system. I thought I'd turn it over to Steve and kind of let him tell y'all, you know, where you evolved over time to where you are right now, and we can get a little more some of the nuts and bolts on the moisture sensors a little bit.
You know, the picture we're looking at is what a grower's used to. As we started to change some things, I asked my banker, why are growers so resistant to change? They said, well, they're just doing what they're comfortable with. And I think that's a whole lot. Mike, I know you've certainly way ahead of me on cover crops, and you know what it's done for you. Growers in my area are just scared to death of a cover crop. It's just different. But my story, and I came back from school in '71, worked with Dad on about 1,400 acres on our family farm, and we expanded a little bit. It's kind of going up and down right now. We were at 48 when I say last year, we're at 43 this year, and it's fluid, it's moving up and down right now. Basically, cotton, corn, and soybeans are our main crops. But you know, everything we do today to try to make things different is for these guys right here. We're looking at 2 generations down, and if we don't do something to reduce the draw on our groundwater, we're going to be farming without water. An example of that, in 1972, we had a well out of the ground about a quarter mile from the shop, and the water level was 20 feet. Today it's 55. That's not sustainable on a 100-foot well. And too many growers just feel like it's there forever, and they may pump 2 or 3 days on a set and just let it run. And we've got to stop that. In the early 90s, we adopted basically stale seed bed, where we started harvesting the crop, cutting the stalks, bedded up in the fall, and then we'd just do a chemical burn down and plant it, and that became accepted rather quickly. And it's still the accepted way to farm in our part of the world. But Bill has caused me to branch out a little bit. You know, let's try this and this. Top left is no-till with a cover crop, and the bottom right And I've always heard if you wet soil or work soil wet, you know, you make it get tight and all. We ran a disc one time and a set of bedders, and it was powder dry on the bottom right picture. Picture says 1,000 words. You know, no-till is better. There's no question about it. That was a couple hours after a 3.5-inch rain. Bill called me and he said, "Have you taken pictures of that difference?" And I said, "No." He said, "Is there a difference?" I said, "I don't know. I hadn't looked at it," and went down the field, and that's what we found. Learning curve with cover crops. Top right was seeded with an airplane. I really didn't think we was going to get that much at the time. It came, I think, 7/10 a couple weeks after we seeded it, and didn't get another rain for 60 days, and really was a difficult situation. But we played around with it, and I'm learning to make this thing work. Return on investment. I started Fawcett in 2008. I was at a crop management meeting in Little Rock, and Phil Tacker was the irrigation specialist at that time. He said, "Get a break." Said, I've got a deal set up in a side room. I want you to come look at this." And I walked in there, and the first thing he said is, "I've got a computer program that will cut your pumping cost by 40%. Frankly, I thought he was crazy. And he started talking about growers that they had played with, and 24-hour sets was now 15 hours or 16 hours. And, you know, I just kind of fluffed it off. And he said, "Steve, I know you don't believe me." He said, "I'll help you set up 6 fields if you'll work with me." I said, "All right, we'll do it." Had a dry May, started had 1,800 acres of corn that year, and we started irrigating corn fairly early. Phil came down and helped me. We set up 6 fields, and by the time the water got out on the 4th one, I said, "Whoa, diesel is pushing $4, may go to $4. We're going to have to do this on the whole farm." So, stupid me, we did, at the time, 4,300 acres, 155 fields, 460 sets in 1 year at one time. A sane grower would do this over a 3-year period. But it worked. I think it put about $100,000 in my pocket that year. And it did just that. It cut most of my fields. It cut our pumping time by 40%. It was just absolutely unbelievable. And the $1,000 I'm going at, I spent about 100 hours right in front of the program that year. And we were getting gallons per minute on the wells. We were getting turn row elevations up. You know, all that other stuff came extra. But we put it in, and guys were all mad at me. I was telling them they didn't know how to water anymore. But it worked. And pretty soon, that was the way to do it. I was asked to participate in Discovery Farm, and they said that they were going to check our runoff water for nitrates and phosphorus. And I said, "Oh, we're not doing that." I said, "I don't want EPA down on my back." And over a period of several months, Debbie Moreland finally said, "Look, Steve, you're the last place EPA is coming. And if you got a problem, we'll help you fix it." And I said, "Fair enough." So we became a Discovery Farm for cotton. We're the only one, I think, in the Mid-South, to my knowledge. I know we're the only one in Arkansas. And you can see in white with black letters that was what we called our fields, and they called them dumb 1, 2, 3, and 4, which dumb was just short for dumbass. But we have some things unique that allows us to do things like this field right here. The water runs back to here, and it runs back to here, so we can split that field on irrigation and do different things, and we can measure it because our site is right there. We're doing the same thing here. Like this year, we've got cover crop here, no cover crop there. Our monitoring is right there, so we can, when we irrigate, we can monitor what's going on with that field. One thing we learned on cover crops, now it's been fairly much in cover crops since 2012. Cereal rye is our main crop. But the north half we did not plant in a cover crop this year. And what we learned, and we decided to go because we've been watering every middle because it wouldn't absorb water. So we went to every other middle. We didn't want to pump so much on it. Well, where we planted the cover crop this year, we were putting 2 inches of water in the soil. Where we didn't, just missing this year, it was 8/10. So we learned that we're going to have to do a cover crop every year. It's not a, let's do it 2 or 3 years and we can slide a couple years. It is a every year thing. Mike, you may have already discovered that, but we documented it, and Bill's always coming up with things. Let's do this different, or let's do that different. And the dumb one, we have surge valve on it. The west half of the field doesn't absorb water, so we've been playing with surge valves to try to get more water in the field. So different things are going on. This has truly been a discovery farm. It's been a discovery farm. First thing, and we'll talk about a little bit later, to learn what our nutrient runoff is, what we're putting in the load going to the Gulf of Mexico, because that canal running down just to the left of Shop and Homeplace does go to Lake Chico, and the excess goes into the Mississippi River. But it's also been a learning process of let's try this, let's try that, and we got the documentation to learn what's going on, and that's been very, very good for us as growers. Questions we've asked, we're able to work, and Bill has been fantastic with working on this with us on that, and coming up with new ideas. All fields are furrow irrigated with polypipe or polytubing, and we've been doing that since 2008. And we of course use computerized hole selection. A funny one when on Mike Daniels, when we first set it up, he said, Steve, I'd like for you to use this program called Faucet on one of the discovery fields, if you don't mind. And I said, Mike, I can't do that. He said, why not? And I said, because we do it on every field. He said, well, could you just not do it on one? And said, no, we're not going backwards. We can't do that either. So after we got past that, we continued. We've added cover crops. Another thing that we learned, and it was from a test that Bill had done years ago, it was a potash test, and one of his timings was 10 days before bloom as opposed to the springtime. And I've always heard all my life that you put out potash this year for next year's crop. It wasn't statistical, but it was numerically for 2 years that Bill did the test before he went to the National Cotton Council. We numerically made more cotton where it ran the potash 10 days before bloom. I said, well, if it'll work on potash, it'll work on anything. And so we just made it standard. We don't fertilize anything until we've got a stand. Another thing that kind of made me want to do that, put a lot of fertilizer out on corn, usually before planting time. What if something happened and we didn't get to go through with that corn crop? So we just made it standard going back to that time. And another thing that we have documented with Discovery Farm, liquid nitrogen, and we do it on the whole farm, as opposed to broadcast. We knife it in. And we have shown, it's not in the slides today, but we have shown where the knifed in 32% uran has less runoff into the water or leaves the field than what urea does. Emitted on the field that I was talking about that has the split, where when you irrigate it, it runs off. Now the interesting thing, even with cover crop, that we let it get to about right here before we terminated this year. And the guy said, you're going to have to run urea this year. I said, no, I think we can do it. We ran a coulter rig with the knife behind it, had no problems whatsoever on the cover. So that was good to know. Of course, furrow irrigation with polypipe faucet to get the hole size. We're working into pipe planter now. Any new fields gets pipe planter. The 4 discovery fields, we have irrigation flow meters that stay there all year, so that we know how much water we pump, how much runs off, and we determine what our infiltration rate is. And playing with the surge valve, we're getting a little benefit out of it, but I can't document what Jason Cruz is getting in Mississippi with the surge valves. The ammometer there on the right is basically measuring evaporation, and that seems to be, it works pretty good on window time irrigation if you know how much water you're getting in the soil. And that's kind of the trick. And my key guy that works with most of the stuff, and he asked Bill at the end of the year, we took a 200-pound hit on a half of the field that we used the thermometer on as opposed to our time. And he asked Bill, he said, well, how do you know how much water you get in the field? He said, well, Perry, that's the art of irrigation. And so we started looking really heavily at discovery fields as to how much we were getting in the fields. And of course the left is just a probe that we were using, and 6, 12, 18 didn't matter. When we started the program without cover crops, they were useless because we wasn't putting any water in the top of the row or even at the 6-inch level. Hydrologic inputs, irrigation and precipitation, runoff volume, NP and suspended solids and runoff, field to market, field print, sustainability metrics. And Bill has been doing the field print calculator, which is real big in Cotton Incorporated. That's something they're looking at really hard right now. And our footprint is real positive from what we're doing. Of course, state-of-the-art automated samplers, trapezoid flumes to measure runoff volume, and every time water goes through those things, it pulls samples year-round now. We've just started that in the last year or so. We pull samples year-round. Every time it rains, if it's Christmas Day, we pull samples to determine nutrient losses. And that was the first year when they were first setting the stuff up. And the equipment as a whole has held up. We've had a little problem here and there, but as you can see, they started out the first year with a pipe instead of the flumes that they went to. The one thing we found out, we can't control what runs off the field when it rains. And as you can see with faucet, we have a very controlled, water's clear. And we've got some slides I don't think they're put in here that does show there's a tremendous difference in the P and K that leaves the fields as well as solids. And I take that back. I remember seeing that. I have looked through them once. And this slide right here shows that. Rainfall, we had 350 units of solids against 19. And our nitrates, 2.07 against 0.03. Phosphate, 0.38 against 0.02. So by controlling what runs off the field, we really control what runs into the Mississippi River. The point that Bill has made with cover crops, making that soil absorb more water, we have less that leaves the field. Therefore, we have less nutrients that leave the field going to the river. And also more applied fertilizer staying where we want it. And I think that's very important. Look at total P next to the last column on the right, 1.1 on rainfall compared to 0.02. Very substantive, and the guys that's sitting there just letting the water run or not using faucet and taking twice as long to get it out, they don't realize what they're losing as well as the groundwater.
And Steve, something to think about on this, because the way these fields are set up, we only have one flume for a field. On an irrigation, we can water one side and then water the other side, and we keep those events separate. But on a rainfall, when we get a big rain, then we get all of it on both sides out. And so these are averages on both sides. So we can't, a limitation of the design of with our flumes and all that, we can't go in and say, okay, well, when we did the no-till cover, this is what we saw. When we did the conventional, that's what we saw. So this is an average across both sides.
Good point.
So kind of keep that in mind when we look at this.
Good point.
And so I would like to think that on the no-till side, that these numbers would be a lot less than that on both the irrigation and the rainfall, especially on the rainfall.
And this represents what? minimal till with covers,
Basically, is Steve, you got your stale seedbed approach. Some years you have cover crop, some years you don't. And on the other side, it was almost the no-till with a cover crop.
Right now, there's the 4 fields in Discovery, 2 of them are with cover crops and 2 of them without. And we ran into a problem with the money. I wanted to go back and put more cover crops in, but we can't do that. We're limited to the fields that we have done it. It comes out of Washington that we can't change this. I mean, they won't allow it because we are getting some NRCS money, so we're very limited on what we can do. If we go back and look at the different fields, and in 2013, I think the shop cut and Weaver was behind corn, and we think that those higher nitrogen losses came from the corn stover. Because the Homeplace has been continuous cotton, and you can see it was lower the whole time. Another thing we ran into on that same NRCS contract, they quit. Well, they never allowed. We got in trouble over it and we quit. But we can't plant corn. These have to be continuous cotton. And but you can see our numbers still have declined each year on every one of those fields. And I think part of that, when we started looking at what our water losses were, I'd say, I think we can do better than that. And we've got it down to where I think the peak has been, 92% efficiency? So we're running somewhere close to 90% efficiency on irrigation. But again, those numbers also include rainfall events. And there's been a year or two we've had like 6-inch rainfall events, which we had quite a bit. But I think that was the main point. And then when you put it to actual applied nitrogen, again, those numbers have declined. We've made every attempt to apply what we think that, a good crop would bring us. And in some years, we've had crops where it was just about a perfect balance of P and N applied as opposed to what the crop actually used.
And you're not farming these fields any different than you are your other fields? You're not doing anything special on these that you're not doing on either?
I am not doing that. That's correct. I do nothing special on these fields other than we started incorporating cover crops on 2 of them before we did the rest of the farm. And we had 500 acres this year. We started out with like 50. And we've kind of steadily upped that. And we've got some more fields, that droughty fields, any dry land field, things that we think we can really do it. Because we're trying not to overload our boat on what we think we can do. And Mike, you probably can appreciate that because you've struggled through some of it here and there, I'm sure. I know we have. Phosphorus, same thing. It's pretty much a declining deal through the years on every one of the fields from 13 through 16. Well, cotton there in 13, we did have an equipment failure and lost the numbers on it. But I guess, being a little conscious of what you're doing, we started doing better. But as far as doing anything different on these fields, we're not really doing anything different, but same tillage and all, except 2 of them did have cover crops. Homeplace does not have a cover crop. Shop does. Weaver does have a cover crop. Well does not. And that's been pretty much that way for 14. So you don't really see the numbers that different from cover and no cover. But we've certainly got a difference in what we're irrigating. And again, percent of applied phosphorus loss is still very low. And again, on a declining basis, as the first picture showed us. So our major findings basically is loss of nutrients less than the model estimates. And I think...
Click on the next one. Yeah, there you go.
All right, here we go. This is what the models are saying that we're losing nitrogen about 23.5% and 3% of phosphorus. And as you saw, that 3% was like 0.2, and the nitrogen was less than 5 instead of 23%. So I don't know where the models came from. We sent kind of a summary and how we got there to EPA when Pruitt was down in Little Rock a few weeks ago to make a point that we don't want to be put in the same category as the Midwest, because maybe we don't have the losses they have in the Midwest, and we don't want to see limitations of applied fertilizer in the Mid-South if we can help it. And they're working on those rules right now. Yeah, there's the
Those are
discovery
your
farm.
ranges, yeah. Your highs, your lows and highs.
That's the low and high, yeah.
And the next one is your average.
And the average 3.2 to 0.7 against 23.5 to 3.1. So I think that's substantive, and it's doable. There's nothing really special being done on these fields that we don't do on a farm-wide basis.
See, I think it's very interesting that your numbers parallel exactly with what the fields we read this morning, saying that, you know, the numbers are so low that we're not contributing. So you're saying the same thing that we're seeing in the other fields.
It's been fairly consistent amongst most of our discovery farms in the Delta.
Yeah. So where did those numbers come from that they're using in the models? Do you know?
My assumption is like what he said, Midwest.
Okay.
I don't know that for a fact, but
I know we asked that question to Mike, and he brought up something that I never thought about. He said that the city of Chicago used those numbers. If a grower had numbers that were higher than that, they would pay the grower to make changes to bring those numbers under that to help get them credits, because their sewage put so much P&N in the waters that they were looking for something to offset what they were doing from their sewage that was going into the river. And so I found that interesting. All this time we didn't know that. And I did a presentation in Minneapolis. Another thing I didn't know, I mean, we have all known about how they put in the tile drainage in the Midwest. What we didn't know was they have a way, or at least a lot of them, they can control how high they hold the water or how low they let it drain. And the higher they hold the water in those tiles, the less nutrients run off the fields. So that was an interesting fact, and it's something that's not really broadcast, but it came out in one of the presentations.
Actually, this training that we did last year was in Illinois, and a big focus of it was that controlled drainage system and subsurface tiles.
Yeah.
So yeah, they were looking at about a 40% reduction in nitrogen that left the field over the year, especially following the corn crop. Now this was specifically following the corn crop, just by keeping those gates and keeping the water table about 6 inches below the surface over the winter. Because basically the idea is you just drain the field once over the whole winter, instead of letting the tiles run the whole time. For whatever that's worth. Something came up that, I'm from Indiana, so something came up
Okay.
that I knew a little bit about what's going on.
You know, you look at that and you first think, gosh, water's not going to go through there, and I think it maybe slows it down a little bit, but it slows it down good. And Bill has been real big. The key word that I've heard him say is we have got to capture more rainfall. And if we capture more rainfall, we use less groundwater
During the growing season.
during the growing season. Yeah.
So you have to slow the runoff and get infiltration.
Yeah.
We took that image just right after you shut the water off.
Now, there's a plow that they're selling in Bernie, Louisiana, that it's got a little coulter that kicks out and a little plow that runs, and then a cone that kind of packs that in.
Bernie, Missouri.
That, that you can run. In fact, we ran it on some fields this year. But the soybeans that we didn't do anything, and they watered just fine. my guys that normally try to complain about everything said, you don't need to do that, water great. And one field in particular that kind of came out here and it dropped over into a bowl, it just had a hill where the beans always just got dry and never made anything. You couldn't tell the difference. And just, this was first year cover crop, and you could not tell the difference where it dropped over the hill and the rest of the field. I think we made that much difference with the cover crop. So I think, Bill, and this is the last one. Yep.
I'll comment for y'all on the potash. There was a man in Phoenix, Arizona, that considered himself the godfather, the father of pedio analysis, Alvin Lingiel. And Woody Miley kind of took all of that information and ran with it. There was a little conflict on that one time. And Alvin Lingiel's thing was fly on potash without blaming. He said your cotton will weigh more. He even did it with his vegetable producers. He said their melons were sweeter, they got a premium for everything. And we were able at one time to find a white potash, which we felt dissolved, because it's discouraging when you would fly it on, watered in, and there's little pieces of brickbat still on the ground. You thought this is a waste. I don't know where white potash is today, but yeah,
We were using standard potash on that, and, you know, I thought it was interesting, because, I mean, I guess it's like cotton needs hot, dry weather. And I asked Bill one day, I said, what's the maximum temperature that's best for cotton? He says 88 degrees.
Yeah. Radio over in Mississippi State did the work in the spark chambers, and basically that's just a glass chamber. It's got an air conditioner, heater unit on it, and all that, so it gets the sunlight, but then you can control the temperatures and relative humidity and all that. And 86 in the day and 68 at night. You just swap the 8 and the 6. Those were the temperature range that we had most of the energy going to our economic yield. When it was hotter, we grew more plant. When it was cooler, we grew more plant. But that's the temperature that cotton liked the best. Blue line is their 6-inch censer, and then we got a 12 and an 18-inch censer there. And kind of coming across, you know, we planted this on April the 19th, and we started getting into bloom. This is on cotton band, but we started getting into squaring, and this is just a measure of squaring those we run cotton band. But this line needs to run parallel to that target, and when it's running flatter than the target, that's indicating you're having stress. And so when we got in here and got to growing, we were still trying to kill pigweed. We didn't have it laid by. We were a long ways from that, because we kept. You know, we got a lot of rain in May. There were a lot of things that we wasn't able to get done and all that. And tropical storm, y'all remember Tropical Storm Cindy that came through? That was that. And at the time, I really felt like that was about 10 days to 2 weeks late on your cotton, because it kept running flatter. Now, I wanted it to run parallel to the target development curve, so it was stressing. It wasn't putting on. When cotton stresses, it slows the rate at which it puts a note on, and it was still being stressed. But I think it's really interesting to look. When we got this big rain or this moisture in this field, it was taking the most of it out of the 6 inches. And when we got this big rain, all 3 of those depths come up. You know, the 18 didn't come up as much, but they come up. And then look at it over time. This blue line is an irrigation. This line started dropping off. We got over here close to first flower, and I says, man, we gotta go ahead and water this, because kind of our threshold on this for irrigation is somewhere between 70 and 80. But we're getting to the point to where, you know, when we get in the flower, if our nodes above white flower are not high enough, then we just don't have the horsepower, and we just cut out early. And so I felt like we had to water early. So we come in and watered, and then you know, we got irrigation. The line kept going down. I think that was the next day we got a rainfall, and then it came up. But I think it's kind of interesting to look to see the 6 inches is doing all the moving. The 12 and the 18 is just kind of, you know, we'd established roots deep, but when we get that hard pan at 6 inches, we just can't get the water through there. But then look down here where we had the cover crops. This is the same field, it's just This is the north side and this is the south side of that field. We got that tropical storm Cindy come in, all the depths come up. But notice how when we get, here's an irrigation, all the depths responded to that irrigation. The 6, the 12, and the 18. And then we got this rain, which one day after that irrigation on this field, it was 2 days after that irrigation because we watered one side and then come back and watered the other side. Then all 3 depths responded again to that irrigation. And so we're getting water down to those depths, and as we come across, you know, they're all coming down. So I feel like kind of what's going on is that our roots, our effective rooting is more evenly distributed through the profile. We're not trying to do all of our work in the top 6 inches. And so I think that's going to help us. And we go back, Steve, remember that picture of that one root I had where all the roots are in the top 6 inches? Mm-hmm. And I tell people, like on our potash recommendations and what you're doing on potash, I tell people that I feel like potash on that is kind of like that interstate between Little Rock and Memphis. If you do the math on that interstate, I'm sure if all the traffic got in a line and moved the same speed and all that like a train, we'd only need 1 lane on each side, and we could get everything back and forth to Memphis. But in the real world, it doesn't work that way. And so we get into potash, and I feel like when I go in, especially when I go into those fields after an irrigation and I poke a hole in the ground and I hit dry dirt about 6 inches, those are the fields that when people bump our university recommendations on potash or go in and put the potash late, like a week before first bloom, that's where they get a yield response to potash. But I go in to other fields where after an irrigation or during the growing season, I can take a soil probe and I can go down 12, 14, 16 inches, and I got good moisture all the way down. I see nice big roots. Those people don't get a yield response in that late application. And so I've got the fertility people up on campus kind of scratching their head because they say, Bill, even if the plant is doing everything in the top 6 inches, you do the math, there's enough potash in the top 6 inches to make the crop. And I think it's kind of like doing the math on all that traffic going back and forth from Memphis to Little Rock. If you do the math on it, it'll work. But not everything moves at the same speed and all that, so it just doesn't work. So I think if we're in a spoon feed situation to where we can't get water very deep, we hit dry dirt about every 6 inches, then what happens if we try to water less frequently and greater amounts, it all runs off. So we are in a spoon feed situation. And so that's when we got to water a little bit, but water it frequently. And I think that's where our potash has to be almost luxury consumption level so that it's almost falling in the root so we don't get into a bind. But if we can extend that root system from the top 6 inches down to the top 18 inches, and a lot of our soils when we get below 12 inches, 12 to 18 inches, it's not real productive, is it? A lot of that we don't want on top. And so I think if we could just do a better job of farming the top foot, I think we'd be so much better, not only just in our cotton, but our beans and corn and everything else. And what I see is our cover crop, I don't know if it's, we're with a cover crop trying to have as many living roots in the soil, as many months out of the year as we can, feeding our microbes, the things microbes do to lend to helping to develop soil structure, keeping that going, letting the water move in. All those things. We got the mycorrhizae helping us get nutrients into the roots, into the plant. There's so many different things going on that I feel like our cover crops are such a key component. And I asked them about cover crops today, and they're going to try it. But I feel like cover crop is I think the main thing that kind of helps tie this together to help give us the benefit. And so I think that's not, and I don't think it's so much the tillage as it is the cover crop. As I tell people, if they want to use cover crop, they can use whatever tillage they want. But if I was going to do no-till, or kind of like what we're doing, the only tillage we do is to do what we can to get the water down the road. If you're going to do that, I think you have to use the cover crop. That's my opinion.
Bill, about a week ago, I sent you some pictures on, you and Kay are both decided it was potash deficiency. Well, that has expanded since in the last week. But I just thought about it. I don't see it in the cover crops.
No. Because just like that cow that goes, you know, you got such a deep feed trough, there's a lot to eat. But if that feed trough's pretty shallow, she's going to eat all her feed right here, and she's trying to start moving everybody else around. So, you know, that just gives us a really big area to feed the plant from. And the plant, it's so much easier. I really feel like the biggest part of why some people have trouble with the university recommendations on our fertility is poor soil structure. I skipped over some slides. There's a slide that I saw, called it the circle of death. And it started with a poor compacted soil, and nothing else around it worked with our fertility and our irrigation and our pest control and all that. It all because we had a poor compacted soil was just kind of our demise. But anyway, that's, you know, I've seen a little bit of response here in this. I'm anxious to get a picker in the field to see what happens. But right now, we've got 5 irrigations in this. I don't know if we're going to need to put another one on there or not. We got 3 irrigations in this. But I'd like to think there'd be a time where we can get back to watering. I think maybe we can water cotton 2, maybe 3 times a year, and
If you can
and
get
be
water on the
profitable.
profile.
Yeah, with this cover crop, we can get into profile. We're going to have to relearn how to water cotton because it's not start the wells every Monday. And I think when we get into something like this 6-inch sensor, the 12-inch sensor, and 18-inch sensor, it's giving me some useful information. I feel like I can justify putting those in and have confidence in those. But when I come over here and look at these, the 12 and 18 is not doing much for me. And then sometimes the 6 responds to irrigation and sometimes it doesn't. It's like when you got a call from the irrigation engineer saying, when are you going to start watering? You say, well, I'm on my 3rd set. And he goes, no, you're not. Because this sensor 6 inches didn't tell him it was. So when we get to where those sensors work for us, then I think all that's going to help put money in our pocket, and our university recommendations are going to work so much better.
In Chris's defense, he came from Nebraska. He didn't understand our compacted soils in Arkansas.
But anyway, those are the main points that I thought we wanted to make, and would be beneficial for y'all. Michael is doing this. You know, we've got some fields we had 2-year averages on, and we look at our out-of-pocket expenses on the almost no-till with a cover crop versus Steve's standard practice. We have 6 cents a pound less total variable cost in our no-till with cover crop. So we're producing it 6 cents a pound cheaper
Than a conventional.
than a conventional. And part of that is, and it's almost a dime on a dry year because we're getting more water in the profile, and so our yields are really better. But when we factor in our yield differences and all that, it's putting more money in your pocket. And so why is it doing it? This is kind of why it's doing it. And some of the data we're collecting, you know, when you visit with you and you visit with Robbie and you visit with Adam, they talk about, you know, when we go to our no-till and the blends and all the different things we do, we don't have to do the deep tillage. We don't, you know, there's a lot of things we don't have to do. And so, you know, we're able to document that why, you know, kind of why some of that's going on. But that's one of the biggest hurdles I had is, okay, I'm conventional till, I go in here and I have a hard pan. Well, the hard pan is just not going to disappear. What's going to happen to the hard pan? Well, it took care of itself, but it took that deep-rooted cover crop to do it. So now I understand why it did it. But in my mind, it's just like, you can't tell me planting a cover crop just made this hard pan disappear, because I thought we had to do some deep till, we had to do something to roll into that. And I'm finding that we don't. And so there's a lot of things that you hear people say, well, when I went to no-till and using a cover crop, it did this. There's some things that I want to holler BS on. But we're able to go in and document that some of those things are.
That was a good rule of thumb. If you're going to go into no-till, you need to break it deep. In the beginning, there was gonna be a big yield hit for the first
Yeah.
year. You remember that? So
Yeah.
the only remedy you could come up with was break it deep,
Yeah.
subsoil, before you enter a
Yeah.
no-till program.
We never
I
got
don't know
much
that
out of
that
deep.
solved it.
We never got much out of deep tillage, and when it was suggested, when we went into the cover crop program, I said, well, it's never worked before, let's see what the cover crops do. And so what would have happened, we didn't try it to do an area of tillage and then follow it with cover crop. But generally what happened whenever we did deep tillage, we had a wet fall and couldn't get the crop out.
Sure.
But it never really saw much yield bump.
And we would subsoil it where the killdees couldn't cross it in the spring
Yeah.
if it was raining.
Yeah.
Yeah.
But Joe Whittington had one of his called DMI, it's a no-till subsoiler. Had that big foot down at the bottom. And it had these, it didn't have rolling baskets, it had just the 2 gauge wheels to kind of firm that up a little bit. And the difference is, and I did that in strips of the no-till, you can see we run this. A lot of this we flew our cover crop seed on before we dropped the leaves, our first defoliation. And then we harvest and shred stalks, so there's a cover crop out there. And we run this out there, and it didn't seem to really impact it any. But by the time we got about halfway through the year, you couldn't tell the difference with a penetrometer. You couldn't tell the difference between where we run it and where we didn't run it.
Goes right there.
And that is on my farm, on what we call, you see my shop back in the background.
Okay. I used to have a neighbor, I still have a neighbor, but he would go out in the fall and we'd have a hard pan, and then I'm at the subsoil, and we'd get 4/10 of an inch. You can take his little engineering flag and say, no, I'm gonna be okay. He's satisfied with you. Not to say that the subsoil was the solution, but he could erase the need for it just with a little rain. Remember we had talking about all of a sudden you can't push that program
Yeah.
here? Well, in the fall, okay, good, so.
And I know some people that struggle, okay, do I do deep tillage in the fall or do I do it in the spring? Because a lot of times if you do it in the fall, by the time we get the rains and all of this, by the time spring comes around, you can't tell that you run it or not. And so a lot of times, I know around Forest City area, a lot of them are very reluctant to do any deep tillage in the fall because it seems like it melts, it comes back together. And so they do their deep tillage in the spring.
But our idea is not to have any tillage in the spring. And you can't, we
don't,
drop down plant.
Let your deep rooted cover crops do that. That'll more than pay what the seed costs.
Yeah, it costs $22, $25 an acre to run a subsoil.
Yeah. That'll buy a cover crop seed.
That's right.
Way more than, we finally got ours down to about $12 a unit.
For cereal rye.
But I'm really, my next step, Steve, is we've got to start going. We're doing the cereal rye. We're just doing to start with, because you get on Twitter and different things and look, and kind of a nickname for cereal rye is the cereal crop with training wheels. And so we got to start somewhere, but we've got to start getting into some blends. And I think that's going to get us even to another level.
Some what?
Into blends.
Okay.
See, I get comfortable with something.
Yeah, we got to move on. The very first year Steve did that, we let that rye get about knee high, didn't we? It's just, but if you have wheat for a cover crop, and we get some size on it, you can't kill it. And they're thinking, okay, if this rye is going to be as hard to kill as wheat, then I can't let it get any bigger. I got to get on top of it now. And so then they kind of understood why we wanted to let it get taller.
Well, we were afraid to,
Yeah.
but we couldn't find the row when it was time to plant, and we finally discovered that's what RTK is for.
Yeah. So now that this year it got this big, and man, it worked great.
The cereal rye is funny. If you kill it a little too early, a month later, you can't get on your knees and find it. It's just,
Yeah.
it dissipates.
Yeah.
It
So
melts.
you had nothing left.
Yeah.
Other than the roots.
And we're trying to work on this air a little bit of a dirty laundry here for the university system, but we're trying to get some of our recommendations a little more uniform. because you talk to our bud guys, and they say terminate cover crops 4 weeks in front of the planter. But when you terminate cereal rye 4 weeks in front of the planter, you got a lot of little ropes out there. You cannot cut through them, and they lean down all this way and the other, and you cannot plant through that. And so our weed guys, you talk to them, they say, well, you know, burn down 10 days to 14 days in front. Most time, like your cereal rice is terminated, but it's still standing up, and a lot of times you can plant through that better. But you know, when I visit with the farmers in the field that are doing it, they're terminated either right in front of the planter or behind the planter. And when we get in a situation like that, when we terminate 4 weeks in front of the planter, the last thing you want to do is roll it down, because it's already kind of wadded up mess, and you cannot cut through all those little ropes, because those stems are ropes, they're tough as a rope. So the last thing you want to do is roll it down. But if I'm terminating right in front of the planter or behind the planter, I think rolling it down is going to make it easier to plant through. And it's going to make it easier when we kind of get into the season on our, when we get ready to post-direct our herbicides and some of those things. If we roll it down in front of the planter, go in and terminate it, kind of get it down. Because the main thing we want is that mat. And so there's, and so some of my recommendations I put out, the last thing you want to do is roll it. Well, that's if we're terminated way in front and you got all the little ropes. But if we're doing it green, well, then I think rolling is probably pretty good. You look what Adam and Robbie are doing when they have their cereal rye in the hairy vetch. The hairy vetch kind of holds it together. They roll it right in front of the planter. And man, the plant's great. And so it's a learning curve for me too. But our university recommendations are not. There's no uniformity in our university recommendations. So we're trying. So on the university, we're trying to work to try to get some of that together too, so that when you come and ask 3 different university people a question, you don't get 3 different answers. It'd be nice if you could only just get one.
So when you say the pest guys are saying, you need to terminate this far in advance, is
Yeah, for the Green Bridge.
are they seeing a specific pest problem or increased pest pressure, or is it just a precautionary thing? Understanding that bridge might exist?
Cutworms is their concern.
Yeah, and then, especially if you have a lagoon cover crop and you're planting a lagoon crop and kind of, I think there's a lot of things that I see, especially on this diversity. When you plant multiple species of cover crops, you have a lot more diversity, and that's better for your soil organisms. But that's also better, when you look at pests, there might be more pests, but there's going to be way more beneficial insects. So having that diversity out there is going to help on that. But when we go through and look in cotton, and you're not going to like to hear this, but when we plant cotton into cover crop, standing or laying down, we hardly ever have to put anything out there for thrips. Mm-hmm. And so there's some of them didn't put any extra insecticide seed treatment on their cotton seed planting into a cover crop because they didn't need it.
But there is one cover crop that attracts through it. So it's either veg or something that I think it attracts.
Okay.
I don't remember what that is because I've been out of cotton too long.
Yeah.
I tell you what threw gas on the fire was that Dr. Mayo near Marble Holly Grove, and he planted in some veg cover crops.
Yes.
And did not automatically spray any insecticide, and that put everyone in a frenzy because he had insects they didn't have a name for.
Yeah. yeah, he had some new stuff in, but the thing is that Green Bridge, and you look at it on paper, you can understand why, because you got this green cover crop out there, and then say you terminate that right when you're planting, so you kill your cover crop. There's pests out there. Well, their home is just gone. So they're looking for a new home, and you got all these new little plants just coming up. And whether it's their favorite bite or not, their favorite food or not, they're going to move to it because they're looking for a home. And so you don't want them to move them off of one thing onto whatever you planted because it might not be something they really like, but they're just hanging on.
One thing most everybody that's done it have said you've got to run, and we found we needed to make it lay down. We run a quarter of Moxone before emergence.
Oh.
And I'm wondering, and that does make it lay down. I had a field I didn't get done, and we had to fly the mixed fertilizer on. We couldn't get it to lay down. And I think we're gonna take some yield hit from that, you know, as well. But gramoxone being as toxic as it is, I'm wondering if that hasn't been an insecticide to also take those insects out.
Acromycin doesn't go out without cheap insecticide,
Yeah.
whether that's correct or not, or preservative.
You know, I'm just guessing, but I'm, you know, it's got the skull and crossbones on it.
But it just blew me away, Adam Chappell this year on his cotton. He didn't put extra insecticide seed treatment on there. And he did not, he did not put a pyrethroid behind the press wheel. He didn't put anything out there for cutworms, he didn't put anything for thrips. And his cotton looked just fine.
Think maybe he was lucky.
Yeah.
That's what Gus told me.
Yeah.
Said, SO, I'm the
You
luckiest guy
can't
around.
scout for that.
No.
You can use scout and the cutworms start right behind it.
Well,
Quick
yeah,
stick,
you know, if they get you right quick, and next thing you know, you're having to replant or spot plant, and I hate spot plant. I hate it. Because the next thing you know, it's like looking at, you know, buddies of mine that, you know, worked in feedlots together and riding pens. You look long enough, they all look sick. And so, you know, when you go out to replant, I have a hard time. Next thing I know, I'm replanting almost the whole field. I just as well been better off just to tuck it out and start it all over again.
And it'll never look right all year.
Yeah, it never looks right, yeah.
And usually, when you need to spot plant, then your main planter man is somewhere else moving forward. And the guy that you wouldn't trust to fill the planter hopper is the guy you put on the replant.
Yeah,
You
me.
trust him with the decision. Yeah, you decide what I'm gonna do now. So,
Yeah.
yeah. We should feel really sure.
Because, you know, on the southern high plains of Texas, on their subsurface strip, they put it in the row middle, in the bottom of the row on 40-inch rows.
In the
'Cause
drill or the middle?
In the middle.
Okay.
Because and they put it every other middle, because that water moves sideways too. And so it's 20 inches over to that row of cotton on either side of that drip tape, and it gets it. Here at Forest City, our friend that has the subsurface drip irrigation, there's one time, you know, he rutted the fields up real bad picking it. He sent his guy out there to disc it real lightly, and he disced the rows out, and he couldn't find the rows, so we had to go up there with shovels to see where the tape was and put little flags out. Because we put this out pre-RTK, and so we had all kinds of crooked rows. And where the cotton was not directly over the tape, you could tell it. Because the water here does not move like it does in other places. And so we got the movement down, but we have the lateral movement as well. And like you said, yeah, most of the time we don't think of water moving sideways as being an issue. We just think of water moving down, but it's sideways.